All right, so now we're going to get a little bit tricky. So we've been talking about the resting membrane. And so I have just colored for you is just the sodium because I just want you to see the sodium. So this is the voltage gated sodium channel and it is currently closed. It is closed when you're resting. Potassium is as well. I don't have it colored for you because we want to focus in on the sodium. And so this is the part of the sodium potassium pump, and I've got again just the sodium part. So when you're at rest, the sodium is actually being pumped out. So sodium's being pumped out. We do have potassium be pumped in. We'll talk about that in a minute. Remember, it is that 3 sodiums. We'll go ahead and write those 2 potassiums, but we're not focusing right now on the potassiums. But because 3 are being pumped out and 2 are being pumped in, it's making us have a negative on the inside. This is that intracellular fluid inside the axon, making it negative there, and we've got it positive here on the outside there like that. And that's called polarized. Polarized was when the inside of the axon is negative and the outside is positive. It's important for us to understand that. This is at rest. And it's important for us to remember at rest, the potential difference was a negative 70 millivolts approximately. So we've got a negative 70 here, a negative 70 all down that axon. So if we get a stimulus coming in, if we get several stimuli coming in, and maybe they're spatial means they're coming from different directions. So excitatory means it's going to allow some sodium. We've got sodium channels that we're not showing on this, but sodium's going to come in to the cell, and so it does come into that dendrite, and these are positive. So what we're going to see is these positives are going to change this negative 70. It's going to increase. It's not going to go all the way positive, but it's going to increase. If this increases enough, and the magic number for enough is negative 55. If that negative 70 goes to a negative 55, something special is going to happen. And so I'm going to write negative 55 millivolts here because that's when our action potential starts. That is known as threshold. If we don't get to negative 55, that's called sub-threshold. If we get below that number, that threshold, we're not going to get an action potential. But if we get to the negative 55, then an action potential is going to happen. And action potentials, unlike the graded potential, which is in here, they are all or nothing. All or nothing. So it's either going to happen or it's not. So you get to the negative 55 or you don't. So that's the way action potentials go. And unlike in the graded potential, which was in the dendrites in the soma, the action potential is taking place in the axon of the neuron. We also will see it on muscles, but for this chapter we're going to see it on the axon. And where it starts is right here at that axon hillock. So if we get enough sodium coming in, and this now becomes a negative 55 millivolts, we're going to see some things happen. And so the first thing that we're going to see happen is this voltage gated sodium channel, which was closed, is actually going to open. So let's write that down. So far we've looked at the resting membrane or cell potential. So it was a negative 70 millivolts, and it's real important for you to realize that the reason that is because of that sodium potassium pump, and it's pumping 3 sodiums out, keyword 3 sodiums out and 2 potassium in, and that's at rest. And the reason that's going to be important is in a moment when the action potential starts, this is going to reverse. So if you know what it is at rest, you'll just know that everything else is going to be opposite that. Okay, so we've got the sodiums that are coming in, and if they reach that axon hillock and we reach threshold, so it's important that you know that threshold is a negative 55. So we started at negative and we were 70 and we're coming up to negative 55, which is more positive. If we reach that magic number and we don't go sub-threshold, an action potential is going to start, and it starts with this sodium channel there. And so this is at the axon hillock. just get that moved out of your way for you can copy that down. Okay, so this is at the axon hillock. It's going to trigger the first voltage-gated sodium channel to open, and then sodium will go into the axon. Remember, sodium was being kicked out by the pump, but this is going to allow sodium to come in. When sodium comes in, anytime sodium comes in inside of the axon, you get depolarization. So sodium's going to go in. Let me go ahead and just move that out of the way there for you can see and write. So sodium's going to go into the axon. As sodium goes in, we depolarize. And what that means is we're going to see the sign change. Originally, we were negative inside, positive on the outside, and that was polarized. So depolarized, we are now going to become positive on the inside. So if we get positive on the inside, that's depolarization. The reason this is happening because sodium is coming in. This is the beginning of that action potential, and it's going to happen. It's like an electrical signal that goes all the way down. So it's like a chain reaction, like a domino effect. So let me come up here and show you, and you can always go back if you need to write that, pause the video. So go back up here for you can see. So at rest, this thing was going on. Remember, those two potassiums were getting pumped in, but we're focusing on the sodium right here. Those 3 sodiums that are getting kicked out. Well, this door is going to get open because when we hit that threshold, this negative 55 is a voltage that opens that door, and this sodium that was getting kicked out is like, oh look, I got a way to come back in. And so it's going to sneak back into the cell. We're going to get sodium in here, and so as that sodium depolarizes, we're going to get some positive going on in here. So we're going to get a sign change, and so then we're going to become more negative here. And so that's going to happen, and then that's going to trigger, this is going to keep going, and that's going to trigger this one to open, and it's just going to become a chain effect all the way down. So what you need to remember for this is that when we hit that, when this stimulus comes in, that graded potential, if it gets enough sodium coming into the cell, the axon hillock at negative 55 will trigger that first sodium channel, and that's going to cause sodium to rush in. The best way to remember this is, remember a salty banana. Sodium is originally, when you're at rest, your sodium's getting kicked out. Sodium's getting kicked out. Sodium's getting kicked out. So when the action potential happens, sodium wants to come back in. Okay, so that's the best way to remember that. All right, so we're going to now see, this was depolarization. We're going to see what happens as this thing starts to become more and more positive. We're about to see another gate open. So see you on the repolarization video.